NVIDIA's LDAT, the Latency and Display Analysis tool, is an incredible bit of kit. It allowed us reviewers the chance to test in games and on displays and even peripherals like mice for their latency, something we didn't really have as easy access to before. The biggest problem with it by far is that only a handful of lucky folk like me got one. If you want to fine-tune your system, games and peripherals latency, you're pretty much out of luck. The good news though is that thanks to all of my work with the open source response time tool, and especially this newer Pro version, I have enough knowledge to solve that problem. This is the open source latency testing tool, or OSLTT. My aim for the latency tool isn't just to make an open source LDAT clone, but to make it even better, even more feature-rich, and of course, more available. Let me give you the highlights. First of all, my custom DirectX test that I wrote for the response time tool is carried over here. That means if you want to test monitors specifically, you can isolate just the on-display latency for more useful and repeatable results. That also means you can capture your system's latency and use it to subtract that from, say, a game's latency. What's new here is this audio jack and all of the features that offers. Namely, listening out for mouse clicks or keyboard key presses, or listening out for the absolutely beautiful custom-made bong sound for the audio latency test. Lastly, if you want to test something else entirely, you can use the 2-pin input to trigger the tool to start capturing light data and time how long it takes between that input being triggered and the light sensor seeing a light level change. Not bad, right? Inside the custom designed and 3D printed case, which also has a crosshair on the top for seeing where the light sensor is on the bottom, by the way, I find that's really useful, you will find my handmade PCB. It's mostly split up into the distinct circuits. The light sensor circuit is here, the mic input circuit is here, the 2-pin input circuit is here, the built-in LED is here, and the onboard button and resistor are here. The light sensor is pretty much the same as the response time tool, just using a reverse mount photodiode and a cutout through the PCB so that all of the components are on the top, which makes manufacturing easier for me, and I think it's quite cool. It does have a fixed resistance, unlike the response time tools, because you don't care about the granularity, you just care about seeing a light level change. As for the microphone circuit, my god, I pulled my hair out on that one. I think it took 5 PCB revisions to get this working. 5! Luckily now I've got it so that it is pretty reliable and has a decent amount of gain but not too much noise. I've wired it to use a mic jack or a 3-pin or TRS connector. This won't work with a 4-pole or TRRS mic, although I am planning on including a microphone with each kit, so you should be good to go there. It's worth noting a couple of things here. Namely that I'm now using a microcontroller that comes with USB-C, which is, it seems like a crazy thing to say, but finally this is actually a USB-C device. And second, the 2-pin input. While I don't think that many people who buy one of these will actually ever use that connection or that input method, it is worth me explaining how it works just in case. If you opt for these fly leads, the one that has the white sticker on it is the positive lead. The other one is just ground. So you obviously connect ground and then supply a voltage to this positive lead, the one with the sticker on it. In an ideal world, you would only supply up to 3.3 volts, as that's what the microcontroller is running at. But because I know that people will forget that fact, I've designed the circuit to fully isolate and protect the microcontroller. It uses a tiny little transistor and 2 resistors, so technically you can supply up to 50 volts and it should be fine, and that is what the transistor at least is rated to. I don't want you to, just in case, but if you accidentally supply 5 volts, 12 volts, or even 48 volts here, it should be just fine. The worst case is that you blow up the transistor, but you shouldn't be able to blow up the actual whole board itself. But also, please don't try. There's no warranty on that either, just to make that clear. Got it? Okay. The software is by far the biggest change. Gone is the dated, blocky styling. Welcome to Material UI. Everything is just a little bit shinier and hopefully easier to use too. All of the settings for the different test modes, auto-clicking and what display to use are all right here on the main page and are set up to not let you pick something that outright won't work. So you can't have the microphone using the microphone to trigger the recording and then also using the microphone to listen for something, at least not right now, although there are a lot of different combinations that you can use with this, and I'm not supporting every possible one at launch, so that might actually change later. But either way, I've also included some preset modes up at the top left to get you easily set up in testing things like monitors, peripherals, headsets, and audio devices, and games. If you want to tweak anything, hit the custom button and then change all of those settings, and any changes you make will be saved so that when you open the software next time, it will reload how you had it last time. One of the biggest differences to LDAT is that almost all of the processing is done on the desktop app, which means that the tool sends all of the raw data to your system so you can validate it all yourself. Now, this is less of a problem on the latency tool compared to the response time tools, but I do prefer the more open nature. You can manually check everything over here rather than a literal black box that just spits out a number. Of course, once the test is complete, you'll get a full results view window, which can graph both the min, max, and average, and show you the individual results in a scatter plot. I find that one is the more useful one for me personally. You can also save the charts as images if you want to, and of course they're fully interactive, so you can drag and zoom and all that sort of stuff if you fancy. I should make it clear though that this is still what I would call in beta. The tests do work and they give pretty reliable data, but there are still a good number of bugs and features that I need to implement. As always, I'm a one-man band building these units by hand, assembling them, packing and shipping, and of course writing all of the, at this point, thousands of lines of code for all of this. If you're willing to put up with some bugs and potentially some missing features on launch, I'm opening pre-orders for a first batch of units at a discounted price to sort of smooth over those issues. The first batch is going to be relatively limited, so if you do want one, you'll want to head to OSLTT.com and pick one up. Those that have already signed up for the mailing list should have already had an email from me, so there's a chance that that first batch is already sold out, and if that is the case, please do sign up to be notified when the next batch is available. I'll be building the first batch basically this week with the aim to ship them in 1 to 2 weeks, and of course you'll get tracking and shipping numbers and information, all that sort of stuff, as always. Also, just to head this one off too, if you do encounter any bugs, please either write an issue report on the GitHub repo, that's github.com/OSRTT/OSLTT, or ping me an email at inbox@TechteamGB.com. Please do include screenshots and as much info about the problem as you can, and I'll do my best to get it sorted, although there is a good chance that since I'm still developing for this anyway, I might already know about it and already be working on the solution for that. With that said, I think I'm going to leave it there for this video. Like I said, if you're interested in picking one of these up or a response time tool, do head over to OSRTT.com. If you have any questions, feel free to leave those in the comments, ping me an email, or even jump onto our Discord if you fancy. We'll also be making the GitHub repo public today, so if you want to check out the circuit diagram in a bit more detail, or check out the software, the firmware, all that sort of stuff, then feel free to head over to github.com/OSRTT/OSLTT. Otherwise, that is kind of it. I hope you enjoy the video. Hope that people enjoy the project as well. Make some use out of it, and yeah, that's kind of it. I'll leave it there. As always, links in the description. You can support in various ways if you aren't interested in buying one of these directly. And yeah, otherwise, thanks for watching. Hope you enjoyed it. We'll see you on the next video.